Where we do this microfabrication, there's several facilities available in Alberta. The first one is the University of Alberta Nanofab. It is a world-class, state-of-the-art facility, one of the best in North America for this type of work. It's set up as a multi-user facility, so university researchers and industrial researchers can go in, learn how to use the equipment and processes, and build and develop their own devices with this. And they have about a $25 million equipment base for this work. We also have in Edmonton the National Institute of Nanotechnology, and although its primary focus is on the nanotechnology, they do have a fabrication facility as well that includes much of the equipment required for microfabrication. Here in Calgary, we have AMIF, the Advanced Micro Nanosystems Integration Facility. They also have a nice little clean room facility with photolithography, metallization, etching capability. They also specialize in the field of laser micromachining or laser machining. So there's really interesting work that comes out of them. You can look on their website for some of the papers that have been published in that area. For Norcada, we're a small company in this area. We make use of other facilities such as the University of Nanofab, University of Alberta Nanofab for our fabrication. And our expertise, our technology involves the design, finite element analysis modeling of the structures. We're very, very familiar with the processes that are required for them, so developing process flows, then doing prototyping and small volume production. Some examples of the work that we do. We got technology developed in the area of hybrid circuit fabrication. In this case, we're using what's referred to as thin film materials, where we can do very, very high quality metallization with fine lines to produce hybrid circuits, where we will have passive components on the circuit. We can add our active components to it. Along with this comes the assembly required, working with high temperature solders, wire bonding to assemble a device. And one of the applications that we're working with in this is where we've got high temperature, harsh environments. We've developed hybrid circuit technology that can run at 200 degrees centigrade reliably. Another application area that Norcada is working on is laser assembly. We're working with the National Research Council in Ottawa to produce a mid-infrared laser that would be very, very useful in environmental sensing. And so our work here is closely associated with ACAMP on the assembly of the laser diodes. And then we're also working to add a micromachining component to it, where we would have an external cavity to tune the laser over a broader wavelength. And the purpose of this, we're working with Boreal Laser here in Alberta for environmental sensing. So by producing a mid-infrared, widely tunable laser, we will have a very high quality environmental gas sensor. Another area of development for Norcada is pressure sensors. We're working on pressure sensors that are designed to work in high temperature environments up to 200 degrees centigrade. With normal pressure sensors, as the temperature goes up, their sensitivity and accuracy drops dramatically. And so we're working with something that's referred to as silicon on insulator material in order to improve the accuracy of these devices at high temperature. So these are a silicon-based chip that could be used for downhole applications. So that's just a sort of a brief summary of microfabrication technology, where you can get it done here in Alberta, and some of the applications that Norcada is working on. I'd be pleased to sort of answer any questions in this general area.